Hello everyone, we're doing a worksheet on Pythagoras Theorem and trigonometry. It contains all the questions related to this topic from the IGCSE past papers. Alright, let's quickly start with question number 1. The diagram shows a right angle triangle. Calculate the value of x. So the side opposite to the angle is perpendicular, and the side opposite to the right angle is called the hypotenuse. So we'll use the trigonometric ratio sine because it uses sine theta equals perpendicular over hypotenuse. So sine 35 equals x over 12. So x should be equals to 12 times sine 35. Enter this in your calculator and we should get the answer 12 into sine 35, which gives us 6.8829, and the rounded off answer will be 6.88. Alright, next up is question 2, where we need to find x. Now the sides between the two angles is the base, and we've already discussed that the side opposite to the right angle is hypotenuse. So we'll be using cos theta. Cos theta is equals to base over hypotenuse. We need to find the value of the angle. Base is 2, hypotenuse is 5. X equals cos inverse 2 by 5. Enter this in your calculators. Shift cos 2 by 5. This gives 66.4218. So 66.4. Okay. Question 3 is find angle BAC. So BAC is this angle. Again, B2A is the base because it's between the two angles, and 3.5 is the hypotenuse because it's opposite to the right angle. So again we'll be using cos theta equals 0.9 over 3.5. Theta cos inverse. So in my calculator I'll enter shift cos 0.9 divided by 3.5, which gives 75.099. So rounded off answer correct to 1 decimal place is this. Angles are always rounded to 1 decimal place. Lengths etc. are always rounded to 3 significant figure if the answer is not exact. Question number 4. Okay. Question 4. Find the area of triangle ABC. So that is simply half into base into height, half into 1.6 into 2.8. This should give us this given answer. Let me see. 0.5 into 1.6 into 2.8. 0.5 into 1.6 into 2.8. 2.24. 2.24. Part B. Calculate AC. So we'll be applying Pythagoras theorem. AC square is equals to 1.6 square plus 2.8 square. To make AC the subject, take under root of 1.6 square plus 2.8 square. So under root 1.6 square plus 2.8 square, which gives us 3.2249. Rounded off to 3 significant figures is this. AC equals this. Question 5. Find the value of length A. So we need A. Before that we will find this length in blue. So this is the perpendicular because it's opposite to the given angle or the intended angle, and 9.4 is the hypotenuse because it's opposite to the right angle. So I'll be using sine because sine uses hypotenuse and perpendicular. Sine 37 is equals to perpendicular over 9.4. So 9.4 times sine 37. 9.4 times sine 37 equals perpendicular. So 5.65706 equals perpendicular. So next we have to find the value of a. Now to find a, this is the hypotenuse, and now this p becomes the base because it's between the two angles. So this is b, which is the same as p of the previous triangle. So we'll be using the trigonometric identities which uses base and hypotenuse, that is cos. Cos 42 equals base is 5.65706 over hypotenuse is a. So to find a, we simply write 5.65706 over cos 42. So divided by cos 42, which gives us 7.61. A equals 7.61. Okay. Next up is question 6, which is from top of a building 300 meters high, the angle of depression of a car C is 52 degrees. So ignore the term angle of depression and just know that this angle given is 52. Calculate the horizontal distance from the car to the base of the building. So we need this length, and this length is between the two angles, so this is called the base, and this is called the hypotenuse because it's this is called the perpendicular because it's opposite to the angle. So we'll use some people have curly tan theta. Tan 52, tan theta is equals to perpendicular over base. So to find x, we'll do 300 over tan 52. In our calculators, enter 300 divided by tan 52, which gives us 234.385, and correct to 3 significant figures, this becomes 234. Question number 7. So question 7. The line AB represents the glass walkway between Petronas Tower in Kuala Lumpur. The walkway is 58.4 meters long and 170 meters above the ground. The angle of elevation of point P from A is 78.3, so just consider it as a normal angle, PAB. Calculate the height of P above the ground. So we need height of P above the ground. So here's the ground and here is P. So they're asking for this whole length. So if you find this length x using trigonometry, you can add 170 to it and get our answer. So in the end we need x plus 170. Now how do we find x? This side is called the perpendicular because it's opposite to the angle 78.3, and this side is called the base because it's between the two angles. So I'll be using sine theta because that connects the perpendicular with the base, and instead of theta I'll write 78.3. So to find x, I'll do 58.4 times 78.3. So 58.4 times 78.3. This gives me this was sine. This is sine 78.3. So 58.4 times sine 78.3, which is 57.1866, which gives now we need to add 170 to it. So next I'll add 170 to this, but this is still not giving me the right answer. Let me check and get back. Yes, because I wasn't supposed to use sine. I don't know why I ended up using it. We have the perpendicular and the base, and tan theta connects the perpendicular with the base, not sine theta. Sine theta connects perpendicular and hypotenuse, and we don't have the hypotenuse in this question, so we'll use tan theta. Tan theta, tan 78.3 equals x over 58.4. Now x will be 58.4 times tan 78.3. 58.4 times tan 78.3, which gives us 282.0029 plus in the end add 170 to it, plus 170, which gives us 452.0029. So correct to 3 significant figure. This is the answer. Question 8. The diagram represents the ski lift in Queenstown, New Zealand. The length of the cable from the bottom B to the top T is 730 meters. So this hypotenuse is 730 meters. The angle of elevation blah blah is 37.1 degree. Calculate the change in altitude h meters from the bottom of to the top. Just a second. Okay. Alright, so let's do part A for now. Okay, we have to find the change. We just have to find h. So h is the perpendicular and 730 is the hypotenuse. So we'll be using sine theta. So sine 37.1 equals perpendicular over hypotenuse. So h will be 730 times sine 37.1. So 730 times sine 37.1, this gives 440.341. So 440 is the final answer for part H. Alright, so this we can't see part of part B, so I've copied it here. This is part B. So for part B, now we're doing 8B. Just a second. Alright, 8 part B. The lift travels along the cable at 3.65 meters per second. So the speed given is 3.65 meters per second. Calculate how long it takes to travel from B to T. We need the time and we have the distance, which is 730 meters. Give your answer in minutes and second. Alright, so time is distance over speed. So distance is 730, speed is 3.65. We'll get answers in seconds. 730 over 3.65. We're getting, this gives us 200 seconds. So 200 seconds is 3 minutes 20 seconds. Alright. Okay, next up is question number 9, which says calculate angle DBC. So where is angle D to B to C? So we need this angle. This is the angle, this will be perpendicular, and this is the side between the two angles, which is the base. So we'll be using tan. For part A, 9A, we'll be using tan theta is equals to perpendicular over hypotenuse. So theta will be tan inverse of this fraction. So in our calculators we will enter tan inverse 1.8 over 2.4, which gives us 36.86 degrees. Show that BD equals 3. BD should be equals to 3. So for that we'll simply apply Pythagoras theorem. Under root 2.4 square plus 1.8 square, and this would give 3, hopefully 2.4 square plus 1.8 square, under root of answer, which is 3. Yes. Alright, next up is question number 10, which is in the diagram. BC represents a building 30 meters tall. A flagpole DC stands on top of the building. From point A, the angle of elevation to the top of the pole is 31 degrees. We can see that in the figure, so we don't have to worry about the terminology angle of elevation. We'll do that next year in grade 9. The angle of elevation on the top of the tower is 37 degrees. That too we can see in the figure. Calculate the height DC. So we need this height DC. So what we can do is calculate the whole height dB, and then from that we can subtract 30 and get DC. So what I want to do, I want to find a DC by first finding dB and then subtracting 30 from it. This is our final agenda. Now how do we find dB? dB is part of this triangle, this whole huge triangle ADB, where this is a right angle. Alright, I don't have dB and I just have this angle 37 and nothing else. So first, this is AB is actually vertical, this is what horizontal. Alright, first I need to find AB using this smaller triangle, this smaller triangle. So in this smaller triangle I have an angle of 31 degrees. I have 30 meters and I can find AB here using tan theta. So tan 31 equals to perpendicular over base. Perpendicular is 30, base is AB. So AB can be found by dividing tan 31 from 30. 30 over tan 31, which gives 49.9. So AB equals 49.9283. This is the length AB. Now I can use this length here, 41.9283. I'll use till at least 4 decimal place, 9283. Now I can find dB. So let me clear the screen a bit. So now the next step is to find dB. And dB would be to find dB, I'll again this side will be the perpendicular and this side is the base. So again we'll be using tan theta is equals to perpendicular over base, 41.9283. Now this answer is already still flashing in my calculator. So what I'll do, I'll write answer times tan 57, which gives me 76.882, but I'm not getting the final answer. Why is that? I'm getting DC will be this answer minus 30, which is not giving us 7.62. So let me see, where did I mess up? Okay, somewhere I've made a mistake in finding AB, so I will need to go back a long way. Okay, yes. So tan 31 equals 30 over AB. Yes, so AB should be 30 over tan 31, which gives 49.9. This is 49. So now this is 49 and this is 37. It looks like 57. Alright, now I'll rub the rest and use this space to find dB. So now to find dB, I'll be using tan again. Okay, so tan 37 is equals to dB over 49.9283, so on. So answer times tan 37, which gives us 37.6. 237. Now I'll subtract 30 from it, so 37.6237 minus 30 will give us 7.623, which rounded off should be 7.62. This is the answer for DC for question 10. Okay, so next up is question 11, which says the diagram shows a point P at the top of a cliff. Alright, so the point F is on the beach and vertically above P point is 15 along the horizontal. Angle of elevation from P is 17 degree. So this angle, it'll probably be given to you in the test or in the exam, that this angle is 17 degree. Alright, angle PAF. Alright, so we need to calculate PF. So we have the angle. Simply, since this side will be the perpendicular, this is the right angle, so this side will be base, we'll be using tan theta. So tan 17 equals x over perpendicular over base, which is 55. So find 55 times tan 17 in the calculator, which gives 16.8151. So 16.8 is the answer for question 11. Next up is question 12, which is in this triangle sine ACB is 9 by 16. Find the length BC. So we're given sine ACB. So let's write that down. Sine ACB equals 9 by 16, right? And also we know sine ACB equals perpendicular over hypotenuse. So perpendicular is x plus 2, hypotenuse is 2x plus 3. Now simply equate these. 9 over 16 equals x plus 2 over 2x plus 3. Next you'll cross multiply and you'll rearrange to get value of, we need BC. So first we need x. So let me do the working here. I'll get 9 times 2 is 18. So 18x plus 9 times 3 is 27 equals 16x plus 16 times 2 is 32. Rearrange, I get 2x equals 32 minus 27 is 5. So x equals 2.5. Now if x equals 2.5, this length will be 4.5 and this length will be 2 times 2.5 is 5, 6, 7, 8. So this length is 8. So now I need the length of BC. I'll apply Pythagoras Theorem. Under root 8 square minus 4.5 square. Okay, so 8 square minus 4.5 square under root gives me 6.61, rounded off answer. Question number 13. Question 13. Alright, so in the right angle triangle ABC, AB is x, BC is x plus 7 and AC is 17. We have to prove this equation. So there's a right angle triangle and there are 3 lengths given, some in terms of x and some one as constant. Okay, so I had to pause and I don't remember where did I stop talking. So I'll revise again. I'll revisit the concept again. We have three sides of a right angle triangle given, and we know a formula that connects these three sides, which is c square equals a square plus b square, which is called the Pythagoras theorem. So I'll apply that here. So I'll write 17 square. C is always the hypotenuse, which is opposite to the right angle, equals x square plus x plus 7 whole square. So this becomes, what is 17 square? 17 square is 289 equals x square plus, I'll open this using the formula a square plus 2ab plus b square, so a square plus 2ab plus b square. This becomes 0 equals 2x square plus 14x plus 49 minus this. So I get minus 240. So when I'll divide the whole equation with 2, I'll get x square plus 7x minus 120, which is what we were supposed to show here. Alright, now let's do part 2, which is factorize this expression. So for part 2, we have to factorize this. So we're looking for two numbers which when multiplied give us minus 20 and which when added give us 7. So what would be those two numbers? So I think 15 and 8 would be the factors. 15 times minus 8 is minus 120 and 15 minus 8 is 7. So x square plus 15x minus 8x minus 120, x is common, we're left with x plus 15, then minus 8 is common, x plus 15. So x plus 15, x minus 8. These are the two factors, and next we have to write down the solutions of this. So this was minus equated to 0 for part 3, and one answer will be x equals minus 15 and the other answer will be x equals 8. Write down the length of BC. BC is x plus 7, so we'll use the positive answer 8 plus 7, which is 15. We can't use the negative answer because that will give us a negative length. Alright, question number 14 next. So again, the diagram shows a right angle triangle. The area of the triangle is 30. Show this equation. So area equals half times length or width time half times, let's say, the product of the base and height. So this, let's cancel these, we get this becomes 2, this becomes 1, then 30 divided by 2 is 15. Open the bracket here, 2x square minus 2x plus 5x minus 5. This becomes 0 equals 2x square plus 3x minus 20. This is what we were supposed to show. Next, factorize this to solve this equation. So we have to use factorization. So we're looking for two numbers which when multiply give us product of these two, 2 and minus 20, which is minus 40, which when added give us 3. So how do we get minus 40? The products would be 5 and 8. So if I write 8 minus 5 is 40 and 8 times minus 5 is 40 and 8 minus 5 is 3. So I'll write 0 equals 2x square plus 8x minus 5x minus 20. 2x is common here, we get x plus 4. Then minus 5 is common here, we get x plus 4 equals 0. So get 0 equals 2x minus 5 x plus 4. So we have to solve this. I'll do the rest here in red ink. So to To solve this, I get two answers, x equals to 5 over 2 and x equals minus 4. So we need the length of BC. So for that, we first need these length. This length will be 4 times 4 over 2 came out to be 2.5. So 2.5 minus 1. This becomes 1.5, and 1.5 times 4 is 6. So this length becomes 6, and this length becomes 2 times 2.5, sorry, 2 times 2.5 plus 5. So this length becomes 10. So now we'll apply Pythagoras theorem on this. So we get 6 square plus 10 square under root. So 6 square plus 10 square under root is 11.6. So this length will be 11.7, rounded off answer. Alright, question number 15. Okay, question 15. Calculate the perimeter of this field. So for the perimeter, we need lengths of all the boundaries. So we have this length, which is 50, then 100 plus 170. So 50 plus 100 plus 170. Then we need the length DC, and we'll need the length ED. So how do we find DC and ED? Let's find DC first. So let's call this X. It's a right angle triangle, so we'll apply Pythagoras theorem. 170 square is equals to x square plus 150 square. 170 square minus 150 square under root, which will give us DC, and DC equals 170 square plus 150 minus 150 square. This is 17875 under root. So I like to stick to the radical form instead of changing it into decimal form. Here I'll change it in the decimal form at the very end. Next I need DE. For DE, I'll use Pythagoras theorem again. 120 square plus 50 square under root. So 120 square plus 50 square under root, answer 130. So now let's add all of these. Wait a second. 17875. Okay, I've made a mistake here. This becomes 6400, not what I wrote. And then under root of 6400 is simply 80. So DC equals 80 and DE equals 130. So this is 80 and this is 130. Now add all of these, and we get 50 plus 100 plus 170 plus 80 plus 130. This gives 530. So the answer for the perimeter is 530 for question 15. Part C1, probably part B was not in the syllabus for grade 8. So it was some other concept which should be discussed later this year. So I've skipped part B. Then part C1. Calculate angle CBD. So C to B to D. We need this angle, and we have all the lengths. So I'll just stick to the lengths which I see on the board. So this is the base, because this length is between the two angles, and this is the hypotenuse because it's opposite to the right angle. So which trigonometric identities use hypotenuse and base? That is cos. So I'll write cos theta equals base over a hypotenuse. Then I'll take cos, to find theta, I'll take cos inverse of this fraction. Simplified, it becomes 15/17. So in my calculator, I'll enter shift cos 15/17, which gives me 28.1 as rounded off answer, correct to 1 decimal place. Okay, this was question 15. Let's do question 16 now. Okay. In the pentagon ABCDE and angle ACB equals angle AED equals 90, there's an equilateral triangle in here and we're given certain lengths 6 and 12. Calculate angle BAE. So we need this whole angle. Now since this is an equilateral triangle, this would be 60 and this would be 60 as well, and this would be 60 as well. And next we need these two angles, this angle and this angle, to find the complete angle. So I need this angle and this angle. So for the angle in red, I'll consider this triangle. This is the base, no, this is the perpendicular. Perpendicular is the side opposite to the angle we're trying to find, or the angle that we have. This is perpendicular and this is base. So which trigonometric identity uses base and perpendicular? That's tan. Tan theta equals to 12, since it's an equilateral triangle, all sides are 12, over 6. So theta equals tan inverse 2, shift tan 2, which gives 63.4349. Okay, next let's find the angle in green. So this is the perpendicular because it's opposite to the given angle, or the angle we need to find, and 12 is the hypotenuse now. So we will, because it's opposite to 90 degree, so you're looking for a formula that uses perpendicular and hypotenuse, that is sine. Sine theta is equals to perpendicular over hypotenuse. So theta is equals to sine inverse half. Inverse sine half, this gives us 30 degrees. So the total angle will be 63.4349 plus 60 plus 30. This gives us 90 plus 63.4349. This gives us 153. Alright, there's another mistake. I seem to be jinxed today. Okay, so this is not 12/6. Tan theta is through perpendicular over base. So perpendicular is 6 and base is 12. Right, so this angle would be tan inverse 0.5, which gives 26.56. So this is 26.5651. This is also 26.5651. Add 90 to it and we get 116. 116.6 as the rounded off answer. Okay, this was part 1. Part 2, calculate AB. 16 part 2. Okay, calculate AB. Where is the length AB? So this is the hypotenuse, this is 12, so we'll use Pythagoras theorem. Under root c square plus 12 square, under root 6 square plus 12 square, 6 square plus 12 square, under root answer, which is 13.4, rounded off to 3 significant figures. Okay, part 3, calculate AE. So for AE, this is the hypotenuse, so which is 12. So we'll be using Pythagoras theorem again. C square, which is hypotenuse square, is equals to 6 square plus AE square plus AE square. Make AE the subject. 12 square minus 6 square under root equals AE. So 12 square minus 6 square. Under root answer is 10.39. So that is 10.4. Okay, next part is calculate the area of pentagon, and you haven't studied trigonometry in detail, so you won't be able to do this one in grade 8. Okay, going to the next question. Question number 17. The diagram shows a pyramid with a square base. ABCD has side 8 centimeters. That means all 4 sides are 8 centimeters. The diagonals of the square AC and BD intersect at M, and this diagonal would be cutting this line into half. Keep that in mind. That's a property of square. V is vertically above M and VM equals 10. Calculate the angle between VA and the base. That's first very important to understand which angle are they asking for. This is VA and ABCD is the whole base. So the angle they're asking for is the angle between VA and the diagonal of the base, which joins with it. So it's always this angle that's being asked. And secondly, which is this angle, right, between these two green lines. And if I connect VM, I have myself a right angle triangle. So if I have right angle triangle and I have 2 of its side, I can find theta easily. So to find theta, I first need AM, and notice AM should be equals to half of AC. So next, how will I find AC? Since this is a square, this would be a right angle triangle. So using this right angle triangle, ABC, this is 8, this is 8, and I can find AC easily using Pythagoras theorem. 8 square plus 8 square under root. This gives me 64 plus 64, 128, under root 128. So I like to use this value for now. So AM equals half of into under root 128. Alright, so now I need the angle. So for that, I'll be using this triangle AVM. Where AM is half under root 128. You may use 4 decimal place answer as well. 128 4 decimal place value for AM as well. And then VM was 10, and I need this theta, so I'll be using tan theta because I have perpendicular and base. So tan theta is equals to through perpendicular over, let me write 0.5 times 128. So now in my calculator I'll enter, this is 128, shift tan, which is tan inverse, times 10 over bracket 0.5 times under root 128, which gives me 60.5, which is the answer for theta. This is 60.5. Okay, next up is question number 17. Okay, question number 18, which is the diagonals of this intersect M. There's a square of side 8 meters, blah blah blah. Find length of PB. So we need no, in fact, find the length of edge P to B. So I need this length, I have this length which is 5 and I just need length MB, and notice MB again is half of DB, and DB can be found using Pythagoras theorem on these two lengths. So this is a right angle triangle, so let me draw that separately. This is D, this is B, this is a right angle at A, and these two sides are A. So dB will be again 8 square plus 8 square, which I believe was 64 plus 64, under root 128. So again dB is under root 128, and uh, this is actually MB. This is not AB, MB. So MB, this was dB. So MB equals half of under root 128. So next I need the length of PB. So this came out to be half of under root 128. Under root 1, 2 and 8. So again I'll be applying Pythagoras theorem on these two. So to find PB, I'll write under root 5 square plus under root 128 over 2 whole square. So let's simplify this a bit. This becomes under root 25 plus under root 128 whole square becomes 128, divided by 2 square becomes 4, which gives us 32. So 32 plus 25 is 57. So this becomes under root 57. So what is the value for under root 57? That is 7.54. 7.55 rounded off answer. So this is the answer for 18A. Alright, part B now, which is the angle. Find the angle between PB is this length and the base ABCD. So it's the diagonal here which connects with the line PB. So the diagonal of the base which connects with PB is DB. So we need this angle right here, and we'll split it into a right angle triangle. So I'll make the triangle P, B and M. This length is 5, and PM from last part came out to be 128 over 2. So now I need this angle, so I'll apply, this is perpendicular, this is base, so I'll use tan theta. Tan theta is equals to perpendicular over base. Let's make this 0.5 times 128. So theta will be tan inverse of this. So when I'll use my calculator to find tan inverse of this fraction, I will get 41.5 as the rounded off answer. Next up is question 19. Okay, so question 19 is part A. We have a kite and the diagonal AC and BD intersect at X. AC is 12, so this length is 12, and BD is 20, and XB and dx is in the ratio 3:3. So this is in the ratio 3:2, and the whole length is 20 centimeters. So applying the ratio, if a total ratio is 5 and the whole length is 20, then 3 ratio will correspond to what values? So 5x equals 60, x equals 12. So this length is 12 centimeters, and the remaining length will be, this is 12 centimeters, and the remaining length from X to B will be 20 minus 12, 8 centimeters. Alright, part A is calculate angle ABC. So A to B to C, we need this angle, this whole angle, ABC. So I may split it into two halves, two equal halves, find one of these angles, and the other angle will be two times of this angle. So I'm finding one angle in blue, and then I'll uh, double it. Alright, so here we know length of B to C, A to C is 12. So the length of A to X will be 6. So now I'll be applying the trigonometric ratio on this. The side opposite to the given angle is perpendicular, and the side between the two angles is the base. So I'll be using tan theta equals perpendicular over base. So theta is equals to tan inverse 3. What does this give us? Inverse tan 3. This gives us 71.56, which is not the correct answer. Let me see where I've messed up. Yes, this length bx came out to be 8. I've written 2 over here. I've written the ratio by mistake. So this is, let me correct it, this is 8. So we have to find tan inverse 6 by 8. And then whatever the answer is, multiply it with 2. So tan inverse 6 by 8 gives us 36.8698. And then for the angle ABC, we multiply this with 2 times this answer, which gives us 73.7 rounded off answer. Okay, this was part A. Part B is find area of the kite. Okay, for part B, I'll split this into one triangle, the other triangle. I'll find area of the two lower triangle, and then I'll multiply it with 2. So I'll write 2 times half times base times height plus half times base times height. This should give us 120. Let me see, 0.5 times 6 times 12 plus 0.5 times 6 times 8, and this gives us 60, and 2 times 60 is 120. Okay, next up is question number 20. The angles of triangles are in the ratio 2 ratio 3 ratio 5. Show that this triangle is a right angle triangle. So the angles of a triangles are in this ratio. So what's the total value of the ratio? 2 plus 3 plus 5, 6, 7, 8, 9, 10. So 10 is the total ratio, and the whole angle, the sum of all angles in a triangle is 180 degree. So to show it's a right angle triangle, we have to show that the biggest angle with the ratio 5 should be equals to 90. So 10x equals 5 times 180. So x equals 90. This gives us 90. So we've shown that it is a right angle triangle. The length of the hypotenuse of the triangle is 12. Use trigonometry to calculate the length of the shortest side of the triangle. Alright, so we know that this was part 1. Now that this is a right angle triangle and length of the hypotenuse is 12. Use trigonometry to calculate the length of the shortest side of the triangle. So we're bound to use trigonometry. So we need the shortest side. The shortest side should be opposite to the shortest angle. So what's the smallest angle here? 10 ratio corresponds to 180 degree, and 2 ratio corresponds to what? Let's find the value of y. That would be 2 times 180, divided by 2, which will be 36, I believe. 180 times 2 divided by 10. This is 10. So 2 times 18 is, yes, 36. So if this angle is 36, the question is asking for this side. Let's call it Z. So I'm bound to use trigonometry. So I'll use, this will become perpendicular and this will become hypotenuse. So I'll use sine theta. So sine 36 equals Z over 12. So Z will be 12 times sine 36. 12 times sine 36, which gives me 7.05, which is not the answer. Something has gone wrong somewhere. No, in fact, it is 7.05. I was looking somewhere else. This is 7.05, so we do have length of the smallest side, which is 7.05. Okay. Next up is part B. So 20B. The sides of a different right angle triangle are in the ratio 3, ratio 4, ratio 5. So the length of the shortest side is 7.8. Calculate the length of the longest side. Alright. So again, we have a right angle triangle. Now, do we have a right angle triangle? The sides of a different right angle triangle. The length of the shortest side, 25. Length of the, okay, now these are the sides of a right angle triangle. So the length of the shortest side is 7.8. So 3 would represent 7.8 centimeter. Calculate the length of the longest side. So 5 would represent x, cross multiply, x will be 7.8 times 5 over 3. What does this give us? 7.8 times 5 divided by 3. This gives us 13. So answer for B1 is 13. Next up is part 2, which is calculate the smallest angle in the triangle. So if the smallest length, this is the right angle triangle, if the smallest length is 13, which we've just found, they're asking for the smallest angle, and we also know the length, no, sorry, we've found that the length of the longest side is 13 in part 1, and we also know length of the shortest side is 7.8. Calculate the smallest angle. The smallest angle is always opposite to the smallest side. So now angle, or the line of the length opposite to theta is always the perpendicular. The length opposite to the right angle is always the hypotenuse. So using sine here, sine theta is equals to 7.8 over 13. 7.8 over 13, shift sign, answer. So this would give us 36.86. So this becomes 36.9 degree when rounded off to 1 decimal place, and that's how you're supposed to round off angles, to 1 decimal place. Okay, the last question of this worksheet, question 21. 10 circles in the diagram, each of radius 1 centimeter. Each have a radius 1 centimeter. The center of each circle is marked with a dot. Calculate the height of triangle PQR. Alright. So the radius is 1, right? So let me see. This side would be 1 plus 1 plus 1 plus 1 plus 1. So this side would be QR would be how many units? 1, 2, 3, 4, 5, 6. QR is 6 units long. 1, 2, 3, 4, 5, 6. Yes, because it has 6 radiuses in it. Similarly, Q to P is probably 6 as well. 1, 2, 3, 4, 5, 6. Yes, and P to R is 6 as well. So the question, calculate the height of this. So it's an isosceles, it's an equilateral triangle. So for an equilateral triangle, each angle equals to 60. So this whole angle is equals to 60 as well. Or you may use half of it and write 30 and 30 here as well. Alright, so I need the height. So this will be 3, half of 6. This is 6 and I need the height. I'll apply the Pythagoras theorem. 6 square plus 3 square under root. What do I get? 6 square plus 3 square under root, answer under root 45 is 6.7. Oh no, sorry, I've applied the Pythagoras theorem completely wrong. It's c square equals a square plus b square. So h will be 6 square minus 3 square under root. So 6 square minus 3 square under root, answer is 5.196. So rounded off to 5.2 centimeters is the height. Part B. Part B. So Mr. Patel uses whiteboard pens that are cylinders of radius 1 centimeter. The diagram shows 10 pens stacked in the tray. The tray is 8 centimeter wide. Alright. Point A is the highest point in the stack above the base BC of the tray. What do we need to find here? Okay, so point A is the highest point in the stack. Find the height of A above the length BC. So we need this height. Alright, so notice these two figures are exactly the same. So I already have this length, and if I add radius and radius and radius is of length 1, so it means if I add 2 to the previous answer, I should get my answer. So I'll add 5.2 plus 2, so I get 7.2, and notice it's for just for 1 mark, so it doesn't need any much working. Alright, so we're done with our worksheet. I'll see you next time. Goodbye.